Welcome back to the channel, everybody. We're out at the large greenhouse, just got my solar panels cleared off, and we got maybe 6 to 8 inches of snow, and it is freezing. We had -10, -11 overnight, and that's not even taking the wind chill into account. We are sitting about -4, -5 outside, and about 51 degrees right next to the door. Now, I observed the lowest temperatures I've documented this far, and it was 42 degrees on this door here, and that is the lowest temps, like I said. So in the middle of the greenhouse early this morning before the sun came up at the coldest point of the day, we were about 50 degrees or so in the greenhouse. We're sitting about 60 right now in the middle, dead center of the greenhouse. I just lit the stove about half an hour, 45 minutes ago, and I basically wanted to come out and talk about a bunch of things that I've learned during the building of this, and a lot of ideas I've got, and some mistakes I've made along the way. First, I had to shed some layers. It is mighty warm in here. We're sitting at least 60, 65 degrees all the time by this thing. And I try and let this thing burn down a bit just so we're using the heat from the coals as opposed to continually feeding a hot fire. And that all comes into basically building a correct system on a stove here. But before we get started, I went and grabbed myself a little speck of something in there, but went and got myself a nice cup of snow. Got the basically stove percolator here, so I'm gonna set this up. I'm gonna start to melt this, and once I get that melted, I'm gonna take the top here. I've got some pine needles in there. I'm gonna make some pine needle tea here. Now, these pine needles have 5 times the vitamin C of lemons, and I really just like to make myself some free tea. This is totally free. Once I get my snow melted up here, I'm going to throw some more wood blocks and kind of get this fire going. Get a little more flame to it, kind of heat it up a little quicker. So I've got these blocks, basically just cut all of them up to fit. You can hear that running through. That's our water coming out there. That's our hot water heater, and you can see we've got a nasty tear. I was reworking this whole system, and I'll cut to the scene where I actually had all of this apart and had to rework it because I had to get a Flue damper put in here, and I want to talk about all that real quick. And that is something I should have done originally, is hook that up, because it didn't come with one. The stove didn't have one, and I thought I could get away with this, but it was not the way it worked. I just really think this is cool. We got this automatic water heater, just cranking hot water through there. But like I said, I basically had to unravel all this and rework all of that, and basically pull my copper off and undo everything that I did so I could install the system I should have installed before I put all of those systems on. So a whole lot of backwards working, but we learn from our mistakes. So I've got all this extra copper. I'll be able to take my little pipe cutter and cut a nice clean fitting on there. Also with that one, I don't like that jagged edge being on that output line there. So I'm going to use this copper. I'm looking at a whole bunch of little heat exchangers. I want to see what I can do with heat exchangers here. I've got this little fan, so I've got one of these fans. I didn't hook them both up. Now this sucker is cranking out some serious airflow there. I don't know if you can see the spider webs blowing in the wind there, but we've got that little fan blowing through basically all 4 or all 6 of those little bricks there. And once those bricks heat up, it's blowing about 102 degrees through decent amount. I don't have an incent to actually show the amount of air that it's blowing, but it's pushing a decent airflow. All the way back here, I can feel maybe 5-10 feet away from the stove the actual air blowing past me. So we're throwing a whole lot more heat into the whole entire greenhouse, and this little fan here is kind of heating up over in this area, kind of pushing a little bit of heat towards our water. And with the negative temperatures outside last night, I'm surprised we didn't have any frozen water. All of our lines were good to go, and everything stayed pretty warm because I had a good fire last night. I knew we were going to have some cold temperatures. It was predicted to be like -16, only ended up being about -10, -11 or something like that. So getting all of this situated, last night for a couple hours I burnt and heated up this water, and I was able to put some decent heat into the greenhouse and into these thermal masses before it got dark and before I basically called it quits on feeding the fire. So our pine needle tea is almost ready to go here. I just grabbed one big bush and basically Took some pine needles from it there. Got most of our water is liquid now, so I'm able to clean this off here and just basically stick it in. Kind of rude and crude, but this is going to get the job done. Got a decent little fire heating that up, so should have some tea here in a few minutes. So I've been learning a ton about proper operation of a wood stove, because I've never really operated one like this old that doesn't have all of the bells and whistles attached, and I just found this online for cheap, so I basically set it up the best I could, and step by step I was realizing what I actually had to do, what I needed, and all of the pieces required to have this stove properly function and really put some heat into this greenhouse. Since this stove didn't come with a flue damper, I actually put my own on there, so having it about half or a little less than half open gives me really good fire, really well fed fire. I can have my actual air damper down here pretty well closed, so it's drawing whatever fresh air it needs as it needs it, and it's a well operating system now. Before I hooked the flue damper up, I was actually using this stove as a rocket stove. This thing was cranking. Once I got everything set up and fed it this fresh air, I was having a super heated cycle, and I was burning through my wood very quickly. And a lot of my subscribers said, hey, you need to do this, you need to add your flue damper, and I got one. I had to go grab one. It cost me like $6 to $7 at our local Ace Hardware, just a local hardware store we have. Since I set this up without a flue on it originally, like I said, I made a big rocket stove generally. This thing was sucking so much air, it was pulling air from the other side of the greenhouse. Every crack in this greenhouse was basically going in to feed this fire and exit the exhaust as fast as it possibly could, because it was unfiltered and unregulated, and that's not what we want. We want this fire to be well fed of oxygen, and it is burning. The flames are licking the top, and they are not forcefully shooting out of the exhaust like they were. So that is a win-win. We've got this situated, and we're putting so much more heat into the greenhouse. We're not just sucking all of the hot air right out, we're radiating a ton of heat. I've noticed at least a 50% heat production increase from this stove, and I don't even have to feed it as much as I was. I was shoveling tons and tons of wood and wood chips in there, all free material that I'm sourcing, but still I was burning through it very quickly, and getting this flue damper installed really slowed that burn down and allowed a lot better heat production into the greenhouse. My subscribers were pointing out any flaws I had in this system, which led me down the path of doing more research on what I'm actually doing here, and basically taking suggestions from you guys, my subscribers, leading me to a well-refined working system here. This is putting out a ton of heat into the bricks, radiating a ton of heat into the greenhouse. We're already up to 70 degrees, and I had just started this fire. So I really appreciate all the input from my subscribers here on this kind of stuff. You guys really know what you're talking about, and if there's something I'm not as educated on, you guys definitely fill me in, and I appreciate that. I don't take any offense to any type of correction in my systems. I'm always learning and sharing the whole process of this, so anybody going to set up a stove can look back through all these videos and say, hey, I don't want to do that, I want to set it up this way the first time, so I can learn from this guy's mistake. Back on topic here, I was pulling so much air through the greenhouse cracks that I had to control my airflow. So I control where the air is coming from. I had dug this out and shown the air circulation cycle, and it's blowing fresh air right across the grate, working very well to control the actual air that this fire is burning. So I basically made the perfect scenario for a rocket stove. Like I was saying, we had all of the fresh air that it could possibly burn and an unfiltered exhaust. It was just shooting right out, and we were losing a ton of heat that should have been up on the top plate of this actual stove and radiated out from the belly of it and exhaust. So I ended up having to take my entire exhaust apart. I still have all my copper coil, and I put another piece of stove piping around it to basically hold all that heat into the actual copper and superheat the water that's coming through here. This pipe gets darn hot, and I really like having this system. It's very simple right now because I lost so much copper coil, but I had a little bit of extra that when this had actually twisted up on me, oh, that's getting hot. So I had actually wrapped a bunch around the belly to pull some more heat off, so we're getting a decent amount of heat put to the water from this. We're not really overflowing it with the pump, so we're actually having a successful system with that stove water heater. When I was taking the actual stove apart, I had to take all of my copper off, and that's how I screwed my copper up, and it got twisted around and basically broke and had a crack on me. In that process of damaging some of the stuff I had already built, I ended up having to take my damper, and this damper was pretty easy to install. I basically just had to slot 2 little holes, and there's a little sharp poker that comes out one end there. I don't really want to touch that stovepipe. It's probably about 500 degrees. So getting that damper was very easy to install. That was very, very easy install. It only took me about 5 minutes and about an hour to get my actual ducting and all of the systems apart and off of it. I had to take all my bricks down. So when I had my bricks down, I ended up putting this little fan back behind the bricks, blowing super heated air out of there, and at a good rate. I think that was like 88 to 100 cubic feet per minute. So that is a very powerful little fan, and it's running off complete solar. So this is no energy used. This is all free heat just being dispersed around the greenhouse. So I did suffer a pretty big loss with this copper where it got pinched off there. I got about 30 feet or so of copper tubing that I'm going to use for something else now. So I'm going to get myself some type of little heat exchanger. Let me know what you guys think about that. I figure I can use this other fan and a small heat exchanger that's maybe about the size of that or double the size of that fan, and basically coil some more copper coil on the top of my actual stack, or maybe down by the belly, and just tuck it in on the side here or something, or just lay it up there. Either way, there's a lot of options and a lot of heat that is able to be accessed. And a simple water to air heat exchanger, like a miniature radiator built for this situation, would work great to add even more heat into the greenhouse. And these will all be systems I'll be able to use winter after winter. So now that I actually got the stove working properly and it's got all the bits and pieces to make it function as it should, I am noticing so much more heat retention and heat radiation throughout the entire greenhouse here. We're putting a lot of heat to the other side that we weren't able to without all of the systems running. So I'm calling this a major success. Like I said, we had really, really cold temps last night, and we held at least 50 degrees in this end and the middle of the greenhouse. Like I said, down on the other end, it was about 42 degrees, and that, I'm just gonna say, is from the draft of the door, because I put little pieces of plastic over any crack, but it's still not 100%. This summer I'm going to figure out a way to make a double door system down on that end so I don't have any type of air coming through. Sounds like our percolator's starting to work here, so I'm gonna make sure this is sealed down nice and tight. So holding 50 degrees is about 5 degrees above where we were with just our John Payne heating. We still got our John Payne air tube going in and coming back out and blowing through all of those bricks on the back wall, pushing the heat all around. That 5 degrees that we held above our normal is saying something. So this stove actually radiated enough heat to keep mostly the entire greenhouse 5 degrees warmer than we were able to just with our John Payne heating. And this kind of picks up the slack by carrying all of that radiant heat into the night. When our John Payne systems and our solar basically shut down, all of this will still radiate heat and shed it throughout the entire greenhouse. We've raised the actual tank temperatures 7 to 10 degrees on average throughout the last week, and it's been pretty darn cold. We've had freezing or below freezing, below zero temperatures, and that's been for almost a week now. So we've had a good week of data collection, and it's been a range of between 7 to 10 degrees. I'm actually raising the temp on this whole tank, and that's only after maybe 2 hours maximum of burning. So I never have this stove burning for more than an hour or two. I get it real hot, and I will do that on the nights that it's very cold. So I'm able to just use this, and I don't continue to burn it. I don't come out here in the middle of the night when I have to work the next day and feed this thing. I will just basically heat it up and run all the systems and passively heat the whole greenhouse the best I can, and then just let it ride overnight, and it's worked for us. This has been very successful. We had good success just with John Payne compost heating, but now that we've added this stove, we've got a whole nother realm of heat that we can disperse into the greenhouse. I'm always trying to better this greenhouse, and I have a great audience that is very interactive and beneficial to the development of all these systems and ideas going forward. So I really appreciate my audience and my subscribers. You guys have a lot of great ideas for me, and we're all kind of on the same mindset with different focuses and different ideas. So everybody's got something different they bring to the table, and I really appreciate all of the feedback I'm getting from you guys. So let's see what kind of temps we can get out of this thing. I wanted to kind of check the temps. Holy cow. 130, 140. That's awesome. Cranking some serious heat out of that thing. Steam rolling off of it. That is absolutely amazing to me, to be able to store that energy as heat in all of this water, thermally sank, and all of the bricks, everything alike. Just storing all of this heat is the #1 key to surviving winter in a very cold environment, especially in a less than well insulated greenhouse. We got 2 layers, but that is about the only thing we got other than some insulation on the ground, and those temperatures are trying to seep in 24/7. so unless you have a very well insulated greenhouse, or unless you have a solid panel greenhouse, you're going to have to work extra hard to be able to grow throughout the winter. I'd like to thank everybody for checking this video out here, and hopefully everybody's learning a little bit from my mistakes and all of the experiments I'm doing. I can really feel that heat blowing off of that brick right onto my face. It is super warm. I'm able to be out here basically in a t-shirt when it's -5 outside the greenhouse, and that is amazing to me. That is pretty darn cool. So I'm gonna let everybody go now, and I will bring some updates once I get myself a little heat exchanger. I'm gonna kind of reset this up and just clean my whole greenhouse up. It's been a pretty rough go at it here. Been trying to rework everything, and stuff just keeps getting moved around. We've had success though. We've got good plants coming. You pretty well watch these on my YouTube grow up from basically tiny little single leaf transplants. All our kale down there, everything's doing well. We are having success. Our plants are surviving. We're able to eat some food, and that's probably going to be the next video. I'm gonna cook some food out here. Me and the kids will be out here probably cooking some food, making some tea and hot chocolate, and kind of hanging out in the greenhouse. So everybody look out for that, and I want to thank everybody for watching this video.